So now in this next R script, what we're going to be doing is we're going to be conducting some basic descriptive analysis of our game data. And what we're going to do is we're going to be looking at, we're going to be loading data, we're going to be summarizing the fields that we have, looking at attendance, score differential, looking at the winners, doing some mean and medians, and then we're going to do some create a box plot, and we're going to create a histogram. And then we're going to take a look at the teams with the most wins and teams with the fewest wins. So just some basic descriptive analytics so that we can understand the teams that are winning. So again, we always start off with a description of the script. We also need to set our working directory. So it's the same working directory as our last script because I'm putting all the scripts in the same directory. So I'm going to do a Control Enter. There we go. I defined the working directory. Next, I'm going to Control Enter and load the library. All right, so now what we're going to do is we're going to load the data file. We're going to use the same data file, the game data.csv that we used last time. I'm going to load that into the game data frame. So when I could do Control Enter. Another way I can do that is with that line highlighted, I can click on Run up here. So if I click on Run, it's going to execute that line. There we go. And we have the 70,182 observations of 35 variables loaded. All right, so the data is loaded. So now let's take a look at the data. And also I could look at the data this way, and I can see my data is there. All right, so first we're going to do a summary command. And let's see what this looks like. So we're going to do a summary command of our attendance observation or our attendance variable from the game data frame. And we use a $sign to indicate the variable, separate the variable from the game data frame. So I'm going to run this. We can see down here that it doesn't just provide one value, it provides a whole bunch of information about that attendance variable. We can see that the minimum value was 0. We can see that the median value was 29,615, while the mean value is 20,439, which shows that this is pretty normalized data. Good distribution, even distribution. We can see that the max data is 80,227 people, and that there's 4 observations that didn't have data captured. So 4 games that we didn't capture the attendance. Now it also shows the breakdown. So we know the lowest value is 0. We know the highest value is 80,000. But we can show the data that falls within the first quarter. If you break up that data into quartiles, the top quartile, or the first quartile, ends at 20,368. We know what the median value is. Right there is 29,615. We can see that the third quartile is 38,596. So that we can break up our data ranges into fourths, and we can see where each of those ranges falls in. So that's why it provides those quartile data, as well as the min, median, mean, and max, as well as the unobserved. So we can also execute this again with our score differential. So we can see that the lowest value is -27 and the highest value is 22, which is consistent with what we saw in Excel. And again, we can see the distribution there. Let's also take a look at winners. So the winners. So what we can see though is winner was either home or visit. So this was categorical data. So that summary command provides different values back. So we don't really have a min, max, and so forth. We can see the length, which means the number of observations that we had. So that means there's 70,182 observations. Well, that actually agrees with what we would expect. And that this was a character value. So it wasn't a numeric value, it was a character value, which is also what we expected, that the value is either home or visit. All right, so now let's take a look if we do the median calculation for attendance. So if we don't want to do the summary, we just want to return just the median value, we can do that with the median command. And we're going to do that from the game data frame. We're going to grab the attendance variable, and this na.rm. So what that means is we're going to remove all values that have a value of na, so that there's not a value in there, so that we don't include those values in our median calculation. So that na.rm equals true means that yes, we are going to remove our non-na values. So Control Enter, and we can see our medians returned, and that is consistent with what we saw up here, but we're actually seeing it including a decimal place. The mean value, Control Enter, we can see our mean value is also consistent, but with decimal places. And now we can also calculate the same thing for our score differential. And notice when I do this, R automatically goes down to the next commandable line. And then to calculate, run that again. All right, so now we show you that we can capture a bunch of information through our summary command, or we can go out and calculate specific descriptive statistics as well. So now let's look at some graphics. So what we're going to do is we're going to take a look at our frequency distribution for attendance. So what we want to do is we want to see what that data looks like. So we already did attendance. Up here we can see when we did our summary command, we saw the min, we saw the max, and the first quarter, third quarter as well. So what we can do is we can execute this box plot command on that data to visualize what the distribution looks like. So what we're doing here in this, we execute the box plot command, and this box plot command it requires some parameters. So inside the parentheses, then it means that we want to take a look at the attendance variable, but we don't want to grab all observations. We're going to filter that. So we use a bracket to where we want to filter only those observations where the attendance is less than 70,000. So we might have some outliers of very large ballparks that we want to remove when we do this box plot. So it's only going to show attendance values that are less than 70,000. And the box plot, we want to have a title on that. So we're saying that main title is equal to game attendance. So it's going to put a title of game attendance on there. And we're going to identify the X and Y labels on this as well. We're going to say that the Y label is equal to fans, and but we're not going to define the X label in this case. But we do want to say that we want this box plot to use the color blue. So when we do Control Enter, we can see over here, we can see our box plot. So what I can do though is quite often this is going to be too small for us to be usable. If we click on zoom, we can see a little bit bigger, and then I can also maximize that so we see a very large instance now. So right here what we have is the box plot of the different values that we have. So we can see that the box plot is going to show us our median and mean as well, and also the quarters. So this shows us visually what our distribution looks like, and we can see that there are some outliers as well. So that's one way to do to look at the data graphically is through box plots, and this is actually a very useful way to look at data to better understand what that distribution of data looks like. All right, so next, what we're going to do is we're going to look at the frequency distribution of attendance. We're going to look at this now through, to take a look at this through a frequency diagram or a histogram. So just like in Excel, what we need to do is we need to establish our bins, right? Establish the different counts that we want to count by. So what we're going to do is we're going to set our bins equal to a sequence between 0 and 9,000 or 90,000. So our attendance is going to be calculated at 0, 1,000, 2,000, 3,000, so forth, all the way up to 90,000. So those are the different buckets we're going to be putting counting our numbers by, and we're going to increment that sequence by 1,000, right? So that means it is 0, 1,000, 2,000, 3,000, so forth, up to 90,000. Okay, and it's important though that that these numbers a line. So if this was going to be 90,100, that wouldn't work because we're incrementing by 1,000s. So make sure that this number, your top number, is evenly divisible by your by command. Okay. And then what we do is we execute our histogram. Well, first of all, let's go ahead and create the bins. Control Enter. And we can see we have a value out there. So that value variable is bins, and that we have 91 values. So 1 to 91 is our number of values. We can see 0, 1,000, 2,000, 3,000, just as we expected. So now our histogram. We're going to look at the attendance data from our game data frame. We're going to break that up based on our bins, which we've established here. And we want to make sure that we include the lowest. So anything that's below 1,000 is going to be calculated as well. So that's why we set that to true. And we're going to use a title called Game Attendance Distribution. And in this case, we just want to include a label on our x-axis indicating that this is the number of fans. So when we execute this, Control Enter, there we go. We have a game attendance distribution. I'm going to zoom in on that and make that full screen. And you can see what that distribution looks like. So a lot of, it is somewhat normal, but there are some peaks in there. But we can we get a good feel for where the attendance records are for these during this time period. You know, there's not a lot of games that had over 60,000 people. Most of the games really fell between 10,000 and 50,000 people. So we have a good understanding of that distribution. But there's also a lot of games that had 0. 500 games actually had 0, which makes us suspicious of some of the data. All right, so now what we want to do is we're going to take a look at the frequency distribution of the winners. So the home versus the visitor winner. This is very similar to what we did in Excel. So what we're going to do is we need to create a frequency distribution table. Now R really helps us with that, but what we have to do is we have to create a table. We can't use a data frame. We have to create our counts, our frequency distribution, our frequency counts in a table. So I'm going to call this table counts, and we're going to create a frequency table based on the game winner and store that data into counts. So Control Enter. There we go. I have that counts table created, and we can see that it has 2 values. I would assume that this is our home win and our visitor win. All right, so now we have that table created. Now let's do a box plot of this, or a bar plot of this. So what we want to do is we want to do a bar plot of our counts data. But first we want to sort the results so that our results that when we show the bar plot, that we're showing them in certain order. And we are going to show them in decreasing order. So the value with the largest value is going to be first, and then the next smallest value, or the next largest value will be second, so forth. Now if we want to do that opposite, where we show the smallest value first, we would do that, change that to increasing equals true. All right. So now we are going to also identify the title for the bar plot. Going to call the X label, going to call that winning team, and we want this bar plot to be in blue. So Control Enter. There we go. And we can see our home and our visitors, and we can see the distribution between the two. Now we did not have to tell R to include 0 in that, like what we did with Excel, which is good. I think that's good. Good default to have. So we're showing the difference between the home team and the visitor team. And we chose blue, but there's a lot of different options you can do and have each one a different color. And you can really get into, with these plots, we can do a lot of different, pass a lot of different variables to that command to really fine tune what we want the plot to look like. But we're just doing pretty simple plots here. All right, so now the final thing that we're going to do is we're going to take a look at the frequency of the teams. What we need to do, we want to take a look at the teams that win the most versus the teams that lose the most, or have the fewest wins. But our data is really not structured like that. So if you remember back into the CRISP DM methodology, that we saw that when we were doing our modeling, which is almost what we're doing here, we had to go back to data preparation. And that's what we're doing here. So we need to manipulate the data a little bit so that we can work with it. So what we're going to do is we're going to create a new field called the winning team, called win team. So what we're going to do is that win team is going to identify which team won. So right now we just know that it's the home team or the visitor team, but we don't know which team that is. So what we're going to do is we're going to create this win team variable, and we're going to take a look at the game winner. If the winner is the home team, then we're going to populate that win team with the home team name. If the winner is not equal to home, then we're going to populate that data with the visitor team name. And that's why we use this if-else command. So if this is true, then this value, otherwise this value. That's what that's doing. And that's going to put that value into the win team. So I'm going to go ahead and execute that. All right, now I'm going to open up my data frame and look at the for our data first. So it was a home visit home. So we saw that the home team was Boston, the visiting team was Seattle, and then the home team was, let's see, I think that might be the Cubs. So that's what we expected to see is Boston, Seattle, Chicago A. And we go all the way down, Boston, Seattle, Chicago A. Okay, there we go. So it calculated correctly. It went in and identified which was the winning team and placed that in this new variable win team. All right, so now we know which team won. So now what we're going to do is we're going to do a frequency table of that win team, so that we're going to be able to do frequency counts for each of this period of time from 1990 all the way through 2019. We're going to count the number of wins each team had. So just Control Enter, and we now have a table that has one row or one observation for each of the 33 teams. So now with that in place, now what we're going to do is we're going to do a bar plot to show graphically the number of wins for each team. But we don't, with the 33 teams, it's going to look it's going to be difficult to look at that. So what we're going to do is we're going to filter this to show only the top 10 teams with the most wins. So we're going to do a box plot. We're going to sort the data. We want to sort that based on our count data. We're going to do a bar plot based on our count data, but first we're going to sort it where decreasing is equal to true. So again, it's going to show the team with the most wins first, and then second most and third most, and so forth. But what we're going to do is we're going to filter that result to only the first 10 observations. So only the first teams with the most wins. We're going to label this this bar plot. We're going to call it teams with most wins. X label is going to be team, and we're going to this time do the bar plot in green. So Control Enter, and there we go. It's teams with the most wins. Let's zoom that into that. And here we can see that the New York Yankees and the Atlanta Braves and the Boston Red Sox are the teams with the most wins during that time period. And you can see that they are decreasing and that there's one bar for each team, each of the 10 teams. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 teams. All right, so that worked as expected. So now let's do the same thing. So we're using the same count data, but this time we're saying increasing equals true. So we're going to show starting with the smallest value, then the next smallest, and starting with the small value, we're going to increment up and again grab only the first 10 values. We're changing the name to teams with the fewest wins. We're going to use the same label, but this time we'll do the bars in red. So Control Enter, and there we go. We look at from the smallest to the largest, and zoom in on that. We can see all 10 teams. So with this R script, we're easily able to manipulate the data. We're able to show some descriptive statistics and do some pretty simple visuals, relatively easy with some pretty simple commands in R. So this script again will help you understand how to do to better understand your data by doing some descriptive analytics, and this includes both looking at the values numerically as well as looking at the values visually.